Surds. The learning objectives. By the end of this session, you should be able to simplify surds, multiply surds, and divide surds. Surds are the roots of rational numbers. Root 49 is 7. Square root of 16 is 4. Square root of 81, 9. Square root of 36, 3. Square root of 2.25, slightly trickier. 1.5. Square root of 9 over 16. 3 over 4. We don't try and find the actual square root of 9 over 16. We leave it as a quotient. We find the square root at the top and the square root at the bottom. So there's the square root of 9 and the square root of 16. Square root of 13 is root 13. All rational numbers have square roots. However, not all of them can be expressed as integers, decimals, or fractions. Those that cannot are referred to as surds or exact values. Calculating with surds can be complicated. To make things easier, we can simplify the surd. This means making the radicand as small as possible. So the number inside the square root sign, we make it as small as possible. To do this, we use one of the rules of surds. Root AB equals root A times root B. Simplify root 12. Break 12 into two factors, one of which must be a square number. So it equals root 4 times 3. So using a rule of surds, this can be rewritten as root 4 times root 3. 4 is a square number, therefore it can be taken outside of the radical symbol. So the square root of 4 is 2, which gives us 2 times root 3. And standard notation is to omit the multiplication sign, giving a simplified surd as 2 root 3. So root 12 is equal to 2 root 3. Simplify 1260. Well, for large numbers, when the square factors are easy to find, there is a systematic way of simplifying the surd. First, express the radicand as a product of its prime factors. So 1260 is 10 times 126. 10 is 2 times 5. They're both prime numbers, so we move to the 126. 126 is 2 times 63. We should see that straight away, divisible by 3. So that's going to give us 3 times 21. And again, 21 is 3 times 7. So we have 1260 as a product of its prime factors. We make as many pairs of the numbers as possible from the list of prime factors. So we've got a pair of 2s, a pair of 3s. So what we can say is that 1260 is a product of 2 times 2, which is 4, 3 times 3 is 9, so 4 times 9 times 35. 4 and 9 are square numbers, so they can be taken out at the square root sign, which gives us 2 times 3 times 35, and we can simplify that by finding a product of 2 times 3, which is 6 root 35. However, this should not be used as your preferred method of choice. It should be for when all else fails. So this isn't how we start to do it. As you work with surds, the more you use them, the more you just start to recognize them and see patterns, and it will work. So this is your last ditch when nothing else works. How to simplify surds on a calculator. Simplify root 208. To evaluate the square root of 208, use this key sequence. Square root sign 208 equals, and the calculator will always give the surd in its simplest form. An important point to bear in mind when dealing with surds. So, using a calculator, simplify root 337. So if you've got a calculator handy, quickly do that. And you'll see the answer is root 377. Not all surds can be simplified. If you can't find an answer, there might not be one. So when you are answering questions or you're in an assessment of any sort, don't spend too long trying to simplify a surd. If the surd's a big number, it's still accurate. It's just easier if we can simplify it. So you have to accept that sometimes you won't be able to. So quickly go through these. Don't expect you to do them all. Just spend a couple of minutes, do a few of them. Once you're happy with them, come back, I'll run through the answers and we'll move on. So pause the video there, do as many as you need until you're comfortable with them. So I'm not going to read through all the answers here, I'll just put them all up, check which ones you did. If any of them are not correct, compare them with these answers, go through it again, find out where you went wrong. So hopefully you got most of them right, or the ones you did right at least. Multiplying surds. To multiply surds, we use the rules. Root A times root B is root AB, and C root A times D root B is C times D times root AB. Simplify root 2 times root 6. Use the rule to combine this into one root. So root 2 times 6. Find the product of the two numbers, which gives us root 12. And from there, we see if we can simplify it. Break this down into two factors, one being the biggest square number you can find. So what's the biggest square number that goes into a 12? It's just root 4 times 3. The square number can be taken out of the radical symbol, which gives us root 3. So if we try and simplify 2 root 6 times 5 root 2, group together the integers and the numbers to be rooted. So we've put together the numbers outside and the numbers inside the radical symbol. So we've got 2 times 5 times root 6 times 2, which that gives us 10 times root 12. And as before, we're going to look at this. And can we break the radicand into two factors, one being the biggest square number? We can. Again, it's 12. We saw that before, which gives us 10 times root 4 times 3. 4 is a square number. That can be taken out of the radical symbol, which gives us 10 times 2 root 3. Again, we've now got two numbers outside the radical symbol. So we can simplify this by finding the product of the two integers outside the radical symbol, which is 10 times 2, which gives the final answer of 20 root 3. Root A times root A. From your knowledge of fractional indices, what does this mean? A to the 1 over 2 is root A. So from this we can rewrite the original expression using indices. So root A times root A is a to the half times a to the half, and to multiply the same base number we add the indices. So a half times a half gives us a to the 1, which is a. To square a surd, just get rid of the radical symbol. So root A times root A is A. For complex equations, we have to be able to change roots into indices and indices into roots. In the order of operations BIDMAS, roots take the same precedent as indices. So roots are indices. As we've seen there, a root is to the power or the exponent 1 over 2. So again, what I'd like you to do is go through these. Again, don't want to spend too long on them. Do it till you feel comfortable. The first 10 or so should be fairly straightforward. As you go down, they get progressively harder. It's worth having to go from the 15 to 18 questions. We won't need them for our work on vectors, but they will help you, if you can do them. Pause the video, have a go at them, and come back when you've had enough. So going through the answers. And if you've got anything wildly different to these, what you have to bear in mind is, as with all of these, human error comes into it. I may have typed something down wrong or just done something wrong. If you're really unsure and you think you got something right, throw it into the calculator. If you did the last 4 questions, really well done. But there are answers. So if you've got any real big mistakes there, go back over and look where you went wrong and correct them. Dividing surds. To divide surds, we use the rules. Root A divided by root B is the root A over B, and C root A divided by D root B is C over D times root A over B. So if we simplify root 8 divided by root 2, we use the rule to write the terms into as a single quotient, which gives us the root of 8 over 2. So carry out division as normal. 8 divided by 2 gives us root 4, and simplify the surds if possible. Root 4 equals 2. So simplify 21 root 24 divided by 7 root 6. Use the rule to write the expression as 2 quotients. So we've got 21 over 7 times root 24 over 6. Divide both terms as normal. So 21 over 7 gives us 3, and 24 over 6 gives us 4. So we've got 3 root 4. Again, simplify the term if possible. The root 4 we can probably simplify there, which gives us 2 times 3, 3 times 2, which gives us the final answer of 6. Right, these surds could have been simplified before starting the calculations. Generally, this will make the arithmetic easier. So when you look at a question, if you can simplify the surds before you start your working out, it will make things easier for you. So it's worth having a spare bit of time, look at the questions. If I can make them easy before I start, do so. So here's your questions. Again, you can see get very tricky as you go towards the end. They're getting quite complicated. The first 10 you should really be able to do. It shouldn't be too much of a worry for you. From there downwards may start scratching your head, but do as many as you need for you to feel comfortable that you remind yourself how to do them. Once you've done that, come back and we'll check the answers. So pause the video there. Right, hopefully you did all right with them. We'll quickly reveal the answers for you. The last 4 questions there were tricky. If you got through them, really well done. All right, that's it for Surds. So manipulating Surds. Remember the general rules for manipulating and simplifying Surds. So root AB is root A times root B. C root A times D root B is CD times AB. And for dividing them, root A divided by root B is root A over B, and likewise for the other ones. When manipulating Surds, it can help to rewrite it using index notation. So you've got to be comfortable with switching from index notation into Surds. Remembering that root A is the same as A to the 1 over 2. Right, hopefully that was of use to you. So a bit of practice, get us back in the swing of stuff before we move on to vectors.